Hello Internet. Today, it's again the day, it's Fun Project Monday. Last week it wasn't Fun Project Monday, but today we're going to have fun designing a nice project, building a nice ID controller without thinking about deadlines, managers, or anything that could in any possibility hinder the fun on designing electronics. Because it always makes fun. It makes fun searching hours for connectors, no problem. Why shouldn't it be? And to top it off, I've got myself some coffee, kept warm. That's great. I hope you got something too. So, let's get right back into the business and see what we want to do. Last week I noticed I made a fatal flaw in the design. I put the MOSFETs the wrong way around in, of course. I think that was the source. The source needs to go to ground, and the drain goes to the upper voltage with N-channel MOSFETs. So that's of course a bummer. I fixed that off screen, and I did some more checking for connectors. And if I calculated right, we don't need a 16-pin connector. We would only need a 12-pin connector. And with a 12-pin connector I thought myself, okay, it could be easier to source 6-pin because all connectors I searched around on eBay getting for different kinds. I searched through the JST catalog, and everything over 10 pins is relatively hard to source. For example, if you're searching for pre-configured cables on eBay, so you don't have some Chinese factory doing a custom length for you, so you simply get an fixed length cable. It's way easier to source 6-pin cables, so I thought we will use two 6-pin connectors. Of course, I did my homework. I decided to use these JST-PH connectors. They are relatively cheap and available as an SMD part. I'm going to use this one, the B6B-PH, and they should be available as a ready-made part here in the trace. So, of course, it's always the same thing. I decided to use this series here. We may not need the 2 amps of rating, but the pitch is it's not as bad. I think it's a 2mm pitch that's quite suitable. That makes our life easier, so I'm okay with having an over-dimensioned connector. Yes. So we get the SMD part. I'm not sure if we should get the side of the top entry part. It actually doesn't matter. I think the top entry part would be easier to handle as a whole. What this train could be, if I think about it, today I've got my drawing set up ready again. I don't. Wait a minute. So now should be sound working again. Yeah, okay, so we got no sound. And I got no chat. That's not good. I don't appreciate having no chat, so we need to go something different. Let's try that. Okay, now I got at least one chat. Okay, I get one chat, that's great. So, we want to use this connector. Yeah, now you hear me and I'm a bit loud. So that should be good again. So I want to use this connector. The problem is, do you want to use a straight connector or a side connector? We certainly won't get the right cable length, and we need to think about putting the device together. So if I put on my drawing, fuck it. So we don't have drawing today. So the problem might be if we have two different parts in the assembly. We could use a straight connector, having some sort of cable in between, and that's of course pretty great. But this of course acts as a force in this direction. Or we could use a connector like this and a connector like this, and have such connection. That helps of course with manufacturing, because if you open the device, you will effectively get this situation, and with that connected arrangement we get a very easy to use setup, because the cable is working as a hinge, or is more or less acting as a hinge. Of course not mechanically, but it behaves like one. And this cable, the other cable, would be completely straight. Not that optimal too. So I think we will go with the sideways connectors. That's great. So let's check if they're available, because in worst case we need to build them into dip trays, and I hope that won't happen. So first of all, I want to get myself a second shed. Let's see if it works. I know that I'm offline. So I don't know how. Yeah, I can go here. Okay, great. Now I have a second chat. I like that. So let's search if we get the right connector. So if I look at the datasheet, it should be an S6B dash PH, and we want all libraries by filter, because if you have this ready, that's of course a lot of time saving. Well, that's a really standard part, or what I see, because everybody uses these JST connectors. So I'm pretty confident that they put it inside the standard libraries. And we're not happy. That's a bummer. But I thought they were available, so let's take a look at it manually and see if we are... Oh, I don't have no interest in going through this. So we will simply use an P6B connector, or use the straight type until we put in the other one, the 6B apply filter. Yep, that is definitely inside the library. We need to see how big the difference between the two connectors is. If it's not that big, yeah, we can use the same footprint. But for first, we will stay with this non-optimal solution, because a non-optimal solution is better than none solution. And I don't have to put in the part, that's of course a big addition. So, let's put the connectors in that corner. So, first connector will be... I wrote something down for my screen. Yes, one connector will only be the outputs of the buttons. So we will use an... so we will name those here. So that will be the quadrature decoder output 1. And we will get the other one. Because nobody liked net names, so we'll put it as quads out 2. And the same thing we will do up here. So what we did is we named this side, and we will simply rename it here. Internet plus another net and 2 UC. Okay. And the same, we'll do the same here. Of course, the same mistake too. And that will be 2. You see, yep. Okay, and we have those buttons that are 2. Then we have those buttons down here. And we have this button here, switch matrix row 3. Yeah, that should be enough. And here we only need to connect them to the net. Okay, of course without a wire. It would be unchristian if you do it with one. I really like to use those labels because then you don't need to lay all the cables or all the connections to the PCB, and they're pretty clean. So that are the quadrature decoder. That are the switches. Side 2. I wasn't able to count. Wait a minute. Okay, and wait a minute. Oh, plus pass. Okay, everything fits. And we put 2 of the buttons in here. Because we have a quadrature decoder output on that side, I want to put the switch output from that side in here too. So switch row matrix 3 and 4 will get connected inside this one. 3. And we didn't name the other ones. No, we didn't. So we'll give them names too. So display name and so switch row matrix will be 4. Just want to get the name. Okay. And we will add them here too. That will be switch row matrix 3. It will get an extra button. And the same thing here. The same thing here. Properties. That is switch row matrix 1. And please display a name. It gets a bit smaller. We'll make that one smaller too. So switch matrix 4. And this will be switch matrix 3. Here we can oh no, yes, I named them completely. Nah, it was matrix or not. Let's keep it uniform. Because if it's not uniform, it's it will be effectively, it's not good. I have the same one here. That looks good. And display name. Name. Okay, I didn't change the name here correctly, so let's change it again. Great, great. And of course without an X. So, and that should be connected now. I hope. We can check that later. And it changed here, that's a good sign. So. And that's with switch matrix row 4. Oh yeah, that's a very good sign. It's only one. There's only one connector, that's a really good sign. And the same thing here, but here we'll connect the other parts, the power supply. So there will be an Oh yeah, we need a 5-volt power supply here. We shouldn't forget that. So we want to have our symbols. Our plus 5 volts here. Put this a bit down, and we will add plus 5 volts. Plus 3.3 volts, and we will add ground, of course. We'll make ground pin 1. Besides that, and I counted wrong, because we are lacking 2 pins. That's bad. So what we will do is, instead of 6 pin, we'll use 8 pin connectors. Why not? That should be B, 8B. 8 pins are also relatively good to source, so I'm okay with that. Okay, now I'm really, yeah. So let's change that directly. So 5 volts, 3.3 volts, ground. Here we'll get all the shift register pins in. So, yeah, I will simply put them with a wire also. With a net name, that's easier. So, that's his HCP. And that's STCP. The data and the storage latch. For some reason last stream I couldn't distinguish them in the data sheet. Or identify them, that was awkward, but who cares. So, we'll add those. Okay. And the storage latch. So, what's left on this one? Certainly needs to put some buttons on here too. So, that's an add. One. Of course, we could use an could distinguish using an 4, and 6, and 8 pin connector. That's of course a really bad thing for the bomb. If you're using multiple parts, it makes things more expensive than they need to be. You don't want that. So what we will do is we will certainly change that. We will mostly use those 8-pin connectors. So we'll trash that. And oh look, for the 8-pin connector. Okay, why is that 2 times in? That's 2 times. I don't know why. SM4. There's no difference. So we'll use two 8-pin connectors. It's good for the BOM, good for parts and cost consolidation. So yeah, good things we can add the 3.3 volts in here. So both connectors will work by themselves. So if we only have J1 in, the buttons will 100% work. And if we only have J4 in, will that work? We need to check that. Do we have enough pins? No, we should. Yeah, we should have enough pins in to have all the buttons run on one and all the 5 volt and LED stuff on the other. Yeah, that would be a very empty connector down there, but good for cost. So, so now we'll do this again. Start with 3.3 volts. Because all the buttons will run on 3.3 volts. Come in. Come in. Come in. Ay, ay, ay. So we'll do this again. To UC1. To UC2. Okay. Then we'll want to have the quadrature decoders out. Oh no, we will first take the pins, yes. We will first take the pins. To net. And there's not enough space for that. That's unfortunate. Okay, we can add another ground. Okay, so that means we won't need those in here. Delete from that and delete from that. Okay, so all the normal switches should work with this one, and all the serial stuff. So all the okay, well, first add those, because to have the quadrature decoder. Okay, the quadrature decoder will only work with if we have both in. That's of course not ideal, but okay, I can work with that. What out 2? Yeah, that's everything. We don't need more. We can release that. It will be J2. Okay. So that should be it for this year. For first, putting in the actual values, we'll do this afterwards. Because if we build it for production, or if we decide to let it assemble, we'll need to add all the specific parts in. So I think if you assemble it at JLC, they have a stock of jelly bean resistors and capacitors, and of course you need to put in the right values. So we can check that afterwards. Because adding everywhere 10k and 22 nanofarad values, yeah, it only makes sense if you actually put in the part numbers. Okay, that looks good. So that should be it for the front panel. Yes, I'm happy with it. If I notice, or if we notice any wrongdoings on my side, any failures or any mistakes, we will find them way before we bring into production. Yeah, but first that's okay. So let's talk about the processor, because I want to change it. Let's change the screen. Let's do browser. Yes. I like this coffee. So, if we take a look on processors, I thought about using an RP2040, so an Raspberry Pi Pico. I'll tell you why. Let's pull up a datasheet. Yes, I'm not a robot, thank you. Give me a datasheet. First of all, the price is unbeatable. You pay 130 for an module, or for the chip itself, and 5 or 6 quid for the module. You get Wi-Fi, that's great. Wi-Fi is not that much more expensive. And yes, one thing that really drives me to using those, besides having lots and lots and lots of processing power, is do we get some general purpose? Do we have some block diagram of the chip itself? No, we don't. No block diagram. Nope. Wrong datasheet. What really bugs me about using those is there are 20 different data sheets for for whatever you want. There is a summary of the module, there is a summary of the chip, and there are 2 or 3 documents for the C SDK. You get so many documents, it's great. And one thing that I think is really nice, they're talking friendly on these data sheets. They're not trying to be that much technical, that much precise in the speech. If I read the descriptions on those data sheets, I have the impression that they're friendly. They're talking friendly to me. That's our chip, it's cool, use it. In contrast to other data sheets. Yeah, so we have a very friendly and nice. So I see that my face is blocking all of the text, which is very unfortunate. So I'll put it to the side. That doesn't make it so much better, but that's good enough. So, one thing I really want to use is, besides price and friendly data sheets, are those PO blocks. So that's effectively a really small processor, besides the main processor up here. And that small processor, you have 4 state machines with 32 instructions per PO. So you can use it to handle all the display driving stuff, all the quadrature encoder stuff. So don't load up your processor with interrupts. Of course, in this application, it's not that important because we don't do so much in our processor. It is, I don't know, checking for some wireless interface if there's data coming. Maybe it's providing a web page where you can remotely set your LED colors, and maybe calculating some effect, but that's effectively nothing. Like it's waiting there doing nothing. So there's no real need to so we could So we could load it up with some LED delaying and LED driving stuff. But having those blocks is something which I'm really looking forward to. Of course, plenty of I/O. And yes, I want to show you the instruction set. It's really small. You can't do so much with them. I think you can't even do addition. So where is it? I hope that's the right data sheet for what I'm searching for. Because, like I said, many data sheets. And well, that's not the important part. No. Is it? Do we have the instruction set? Yeah, you don't have addition. We don't even have an increment. To increment, we have to inverse and then decrement and inverse. It's it's really barbaric, but definitely good enough because you don't need so much. And what they do, it's really miracle. Like they're doing VS 1228B driving with them. They're doing quadrature decoding with them, and all the code is already ready. So we can let ourselves inspire us. We can let ourselves be inspired by the code examples they gave. That's very nice. And yes. Well, yeah, they didn't help so much. But I'm certainly sure we will use this processor. I decided that now. So we can start working on the control logic. And for that, unfortunately, the Pico is not... there's some other pictures, but they don't matter. Of course, it's an yeah, great device. So what I wanted to have is the pinout reference, but of a module, because I think we need to put it inside. No, Pico V, because we need to put it into libtrace first, because it's not available yet in the standard library. So we need to... No, I don't want that. I want to only have a big picture. Copy, open image, new tab. Yes. So I want to have this. And we will put this into libtrace now. To do our control circuitry. One other thing I noticed that I ignored is that we should use some, of course, add some resistors at the gate here. I once thought should really use them, but it's nice for the chip itself, for the control chip. If the outputs aren't loaded with amps of currents, if we gate switches. Because at the point where you switch your MOSFET gate, you have very high currents that can potentially flow through your microcontroller or your transistor that you use to drive your MOSFET. And that's of course not so nice for the long-term use, but the long-term reliability of your device. So you want to reduce that risk. So let's go to the fun part, of course, and design the control circuitry. What was that? Okay. So for that we will use the 3 viewers. Wow. For that we will use the pattern editor. And we will use the, first of all, the component editor. And add another library, or another part of my library. Of course, this library is available on GitHub under my International Kaffeeapparat. So if you're using diptrace and you need to add some parts, use this. There are some parts available. But first we want to add another folder. Want to have... no. I always get messed up with this. No. Yeah, I want... so yes. I want to add a new library. Yeah, thank you. I think that's pretty obvious. So we will add our PicoV module. For that we will need 20 pins on each side. Okay, no, we will do it a little bit. Do it a little bit more schlauer, a little bit more clever. Because we have our I/O is grouped, so we have a few grounds. Of course, now you see because of my face nothing, but I don't care. So, of course, we have different ground pins, we have different power supply pins. So what we will do while designing the pattern for our schematic, we will consolidate all the different pin types. So, for example, we will add how many grounds we have? We have 1, 2, 3, 4, 5, 6, 7, 8 grounds. Let's say we have 8 grounds. No, we have 9. We'll definitely add that software debug option too, because maybe we can integrate it in some sort on a PCB, or someone else who uses this library will do this. I don't know. Maybe it will come in handy. So we will definitely put VSVD inside, and that's everything. Can I name them? Can I name them here? Name. That's all ground. First bin, step 1. That's everything ground. Did it work? Nah, didn't. Pin manager. It was worth a try. So that's everything ground. We will not bother to name those grounds different, there's no need to. But what we certainly will do is we will put the right pin number besides that. So we have... okay. So one ground is 3. One ground is 8. One ground is 13. One ground is 18. One ground is 38. 38. One ground will be 33. One ground will be 28. And one ground will be 23. And the last one will be an... oh, that's good. That's a good guess how we should them. That should be 32. That's the software debug. I will label that one definitely differently. Going for software debug or SVD. Yeah, ground SVD. that will get an extra name. That's special. Okay, that was that. Then I'm wondering how many. Okay, we have. Then we have some power supply stuff. We have three power supply pins. That will be 2, 3. We will name them directly, so we don't forget what we're for. That are the bus. The sys. And 3.3 out. V3. So the Pico seems to be 3-volt tolerant. Then there are 2 special pins. I didn't 3.3 enable and run. I didn't have to use them until now. I'm interested what we're for. But we'll check that later. We'll first of all finish this. Enable. And that will be run. So, and then we have plenty of GPIOs. Come on. Let's see. 0, 1, 2, 3, 4, 5. 28 GPIOs. Let's think, how should we place those? Yeah, we'll do like this. All the actual power pins will go on the right side. And the GPIO pins will be placed according to the side on the Pico itself. So we want to have 15 on that side. And we want to have another 12 on the other side. And that's a Pico V module. So now we can certainly use the array function. Pin array names. So we start with 1, stop first pin 1, step at 1, yes. And then that strings very simply GPIO or GP, doesn't matter. Let's take GPIO, that's more nicer. And if I've done everything right, we should hear GPIO 15. Great. Same thing down here, from 16 to 28. You want to have pin array names from bottom up. Start at 16, step 1. And here we go. And of course now we could start to add all the, let's say, display name. So now we will need to add some text. So I'll put my tablet that's not working today to the side. Actually the tablet's working, but I messed up with my sampling setup. And now we add all the parts, all the different numbers as a text, so we can actually use it in a schematic and it's readable. Everybody likes readable schematics. So GPIO1. So we will add some a little bit of space between those. Of course, you could start adding our function to it, but I won't do it right now. I would like to make them spaced out, or nah, I won't make them so spaced out. That's good enough. And of course, can I have a space here? Yeah, let's do some. Yeah, that doesn't look that good. So I want to have a little bit of more of line spacing. So that should now be okay. Or maybe 2 is better, but I think when we are at the... No, 2 is great. 2 is great. So now we can aesthetically pleasing add the pins here. Genau, why do I have to too much? Oh, because it starts at 0, okay. It starts at 0. Let's do it again, and again, and again. Of course, if you're building in such microcontrollers, it's always a good idea to add all the alternative pin functions. Okay, now I did add 15, didn't I? Oh yes, I didn't. I also added GPIO 0. Didn't add GPIO 0, correct? Yeah. So let's add GPIO 0 and we're happy. Okay. So now we can add now it's the same one but for the other pins, so 16, 17, 18, 19, 20, 20, 21, 22. Oh, there's quite a gap. 26, 27, 28. We're missing some. That's unfortunate. But not further disturbing. That means I need to delete some here too, which should be 28. 27. 26. So I have 25, 24, 23. You're gone. That should be 16. Right, yeah, that's 16. That should be okay now. So. So and so, and we added 28. What are the grounds? Correct. Yeah, that's the grounds. That is 28. Okay. I just noticed that I'm doing this way. Ah, fuck that, we'll use those. Fuck that. Almost forgot that this was an option too. So, let's again show name. Can I select all of those? Ah, no, I can sort of, so. Great. Yeah, now I'm happy. So we have all the GPIOs. Some space to the bottom. Space to the right. a bit more space up. And we will add the SVD again. Oh, not again, but we certainly will add the SVD. And after that, simply copy those two assign pin numbers and we're done. We won't do the pattern directly. And start building up the circuitry, control circuitry. So let me check something down here. Oh no, I hate it. I hate it. I always forget to change the... I always forget to change the screen, oh my god. I will change my setup a little bit. Yeah, I will change my setup the next time, that I always see my screen in a more prominent position. Or I should more often look to the left. You know, I have a two-screen setup here. One screen with the two windows I mostly use, and another screen where the chat is and everything, and I'm always, of course I'm focusing on the work itself. So I don't think about actually looking at the other screen. So you don't see anything. That's unfortunate for you. That's really unfortunate for you. Okay. Oh yeah, we added everything here. So let's add SVDIO. And SVD clock. Make it a little bit smaller. Till I didn't add the bit more space at the top. Okay. A little bit more space at the top, it's great. We put those grounds further down. Yeah, we'll do it like this. We'll put the grounds at the bottom and the software debug on the bottom where they belong. And that is allowed to stay up. We add the GPIOs top 2. And that gets down here. I'm tempted to split it into 2 parts, but I don't think it will be that necessary. Just put a bit further down, yeah. I certainly like that, yes. And we put that in your side here. Pico emoji. Okay. And this I will put on the different side, yes. The opposite side. Because that's a little bit special. Yeah. Can make it a little bit smaller. Yep, that's great. We will certainly save that. I want to name this Pico V. Can be a U, doesn't have value. And doesn't really have an... Oh yes, we still need to add the pin names. That will be fun. Let's start with the ground. 3 is good, 8 is good, 13 is good, 18 is good, 33 is good, 38 is good, 28, 23 is good. Yeah, that's everything great. And then continue. 3.3 out is 36. That's 36. Thesis is 39. The bus is 40. Run is 13. That's 37. 37. GPO 1, 2, 4. Oh, that's... No, 3 was... No, 3 was 5. No, that was 2. 2 was 4, 5, 6, 7, 9, 10, 11, 12. GPO 10 was 14, 15, 16, 17, correct. 14 was 19. Let's go down. 15 was, let's check back, 15 was 20. Yeah, 21, 22, great. 24 was, 18 was 24. Oh no, 27, I'm 27. 27 was 33. 33. No. 32. 32. 26 was 31. 28 was 34. SVD clock was 41. 43. GPIO 22 was 29. 21 was 27. 20 was 26. 19 was 25. 18 was 24. And 17 was 22. 16 was 21. 0 was 1. Yep. Then sort by number. See if it makes sense. That looks good. Let's double check, because that error can be really expensive and annoying. 17. Although the PO interfaces give us lots of how do you call it? Lots of flexibility. Will still need to be GPIO 22. Yep, that's correct. 18, 19, 18, 19, 20, 26, 27, 21. You don't know how confusing that is if you have that kind of number combination to double check. It's a pain in the ass, you know it. 31 was 26, 27. Yep, that looks good. V-sys, V-bars, yes. That looks good. Okay, that's ready. Prepare foundation, good. So now we can add this into the control circuitry. Oh yeah, I mean, still need to save my libraries. Examples, no. Now I need to remember where I put my libraries, but it's most probably in the, yeah. That was a component. That is a Raspberry Pi Foundation. Okay, that's saved. So I'm certainly happy in that regard. Should be available here right now. Oh yeah, first of all, I can add those in. That will be our connectors from the front panel. Pico-V. Okay. Good. Good. Can connect all of those. Put that to ground. So, and of course you need to think about the power to the Raspberry Pi itself. Unfortunately, our power drivers are they are full with supplying the LEDs. So it would be a good idea to add another power regulator for the Raspberry Pi. I mean, we buy the... Oh, let's think about it. Yeah, we should add a separate power regulator. It would be a good idea. Because if some of those... because if some power regulator is giving up because of noise, it is... or because of too much current, too much power, and that device would get, I don't know how much current it actually draws, but with Wi-Fi enabled it would be a substantial amount. We will add another power regulator for this part. So let's go to TI. Add this one. Yeah, it certainly should. Yeah, I'll change the names later too. But yeah, it will get its own power regulator, but a fixed one. No experiments here. With the connectors, that will be J12, or that will be J11. The connector J22, J21, and here the front panel will be J12, so it's obvious for everybody that they are connected. Yeah, but that should be enough for today. I'll stop the stream after I have changed those. So great that we're using a different processor now. Great that the front panel is ready without finding any mistakes. And then we will take a look on the control circuit in the next time. Control circuit shouldn't be that much of a hassle because it's more or less connecting pins. After that we will add some resistors to the MOSFET and then calculate some values. The most fun part. Okay, goodbye.